Hello learners, welcome to Education Online program. In our previous lesson, we looked at examples concerning velocity time graph, how we can get the distance under that graph, the retarding force. So today we are still going to continue with the same thing. So we're going to look at one example under the same thing, velocity time graph. So our example for today is like this. We're talking of a car traveling at 10 meters per second is uniformly accelerated for 4 seconds at 2 meters per squared second. It then moves with a constant speed for 5 seconds, after which it is uniformly brought to rest in another 30 seconds. So they want us to draw a velocity time graph, and then we'll have to calculate the total distance traveled. So what was the distance the car traveled? So for us to do that, obviously we shall first have to know that to have our representation of the whole of this work in the velocity time graph. So let me first write the question down. We're saying that a car traveling at 10 meters per second is uniformly accelerated for 4 seconds at 2 meters per squared second. It then moves with a constant speed for 5 seconds, after which it is uniformly brought to rest in another 30 seconds. Roman numeral 1 is telling us to draw a velocity against a time graph. We have Roman 2 telling us to get to calculate the total distance traveled. So that is our question. So if we know our question, we have it like that. How do we summarize it? So if we want to summarize this, we can first also draw our velocity against time graph, or we can first try to find out what is in each stage of that traveling and what is lacking, so that we find it out. So if you see that, let's try to draw, to represent the whole of this motion in the velocity time graph. So we shall have it this is our velocity time graph like this. Then we move with this. This one will give us the time for the whole travel, and this one will be indicating for us the speed with which the body was traveling. So they are saying that a car traveling at 10 meters per second is uniformly accelerated. So if you look at our question, our car wasn't starting from rest. So the car was already moving with a given velocity. And in this case here, our given velocity was 10 meters per second. So instead of us starting our acceleration from this 0 point here, we shall start it from a point where the body had attained already the 10 meters per second, which is somewhere along this line here. Because here we shall have our time in seconds, and then here we shall have our velocity in meters per second. So what happens is that, let's try to see that from this point we are going to assume that it is at this point here that the body was having the 10 meters per second. So here if we have our 10, that velocity, the question is saying that it is uniformly accelerated for 4 seconds. So we are trying to accelerate our body here, our car, uniformly like this. For how long was the body accelerating uniformly? The question is telling us that the body is accelerating uniformly at 4. So if it is accelerating uniformly at 4 seconds, so our timing here will be 4 seconds, will be right here. So that way, this 2 meters per second squared is the rate, is the acceleration. Let's continue. It then moves with a constant speed. When we talk about constant speed, it's the same as a uniform velocity. So here our body moved with a uniform speed for how long? For 5 seconds. So we are moving from this point. We are giving it a uniform velocity right here. For how long? We're giving it for 5 seconds. So instead of us just writing like that, instead of us just having 5 here direct, you'll see that when you try to get the time interval just between this 4 and 5, it will be 1. So we are going to make it in a way that the number we introduce here, when you subtract this number here, we shall get only this distance here, the time interval around here. So this time, instead of us writing 5, we shall have 9. So now what happens is that after which it is uniformly brought to rest. So now our car is coming back to rest. So we are giving it here, this is the retardation. We bring it back to rest here. How long did the body take to come to rest? The question is telling us that it was brought to rest in another 3 seconds. So it took the body 3 seconds to come back to rest, or to hold the brake, to stop moving. So 3 seconds, instead of writing 3 here, we shall have 12, because 12 minus 9, we shall have here 3. So with this we have represented our whole journey here of the car in the graph. Because our Roman 1 was telling us to draw a velocity against time graph, and this is our velocity against time graph. So what is it telling us? It wants us to find the total distance traveled. How shall we find the total distance traveled here? You see that you have to divide your motion into stages. So here we have our stage A, we have our stage B, and then we have our stage C. So if we have it that way, what is the shape? Which kind of shape is this? So if we know the shape, then we can easily find the area of that particular shape to give us the distance covered by the body at that stage. So if you look at stage A, what kind of shape is that? with stage A. So you'll see that our stage A here is a trapezium. So if you can know that it's a trapezium, then how do you find the area of a trapezium? So to find the area of our trapezium, we have this formula here. Stage A, if it is a trapezium, the area is found from this. Area is equals to a half height. We have A plus B. Where is this A and where is this B? So if you look at a trapezium, let me draw a simple one here. Something like that. So this is our trapezium here. For you to know which part is A, okay, this way. On a trapezium, this one here, the longest side here, is our B. And this short side here becomes our what? Our A. So I guess we've got that. So this is our A, and then this is our B. So you can come and check here which one is your A and which one is actually your B. But then how do you get the height here? Because if you look at this, we don't have height. We cannot use 10 and say that it is the height. Because if you're looking at the height of this trapezium here, it is at this point here, right somewhere up here. So that is our height. So how do we get this? Okay, this one is the height, I mean, so this is B. B is from this point up here. But then here, this value has not been given to us right here. So that means that we need to find the value of B, because we have the height of the trapezium, which is this point here. Then we have this other distance here as the A of the trapezium. So when you extract it from there, let's try to extract our trapezium from that point. It is something like this. Up here. Something like this. We are just extracting the trapezium from that, from our graph. So we are taking this long side here, which is from up here, up to down. From where the body accelerated and then attained the uniform velocity at this point, become this up to down is the B. So this one, if it is the B, where is the A? Our A is the short length here. What of this point here? This one is the height of our trapezium right here. Is the height. So we have here, if you check, we already have our A. What is the A? A is from this point here up to here, which is 10. That means our A here is equals to 10. What of the height? It is from this point, it is the seconds, the time interval taken for the body to accelerate up to when it attained the uniform velocity. So here, this point here, our height is equals to what? Is equals to 4 meters. So what of the B? How do we get B? To get B, that means we need to know the velocity. When was the at this point here, what was the velocity the body attained? What was the final velocity for the body to accelerate with uniformly? So if we know that value of that final velocity for stage A, that one becomes our B there. So let us find it. To get our B, we see that the car was traveling at 10 meters per second. So that means that here was our initial velocity. So the initial velocity at that point is 10 meters per second. It was accelerated uniformly for 4 seconds. So our time interval there was 4 seconds at 2 meters squared, 2 meters per square seconds. So if we have 2 meters per square second, that one is our acceleration, which is 2 meters per second squared. Now you have that. What don't we have in the whatever? In our question, we do not have the final velocity. So our final velocity there is the v. How do we get the v? We can get our v from the equation of motion, the first equation, which is telling us that our v is equals to u plus a at t. Our v is equals to, our u is 10 at this point here. Then we have our acceleration already given to us as 2 times the time taken for the body to move, to accelerate was 4. So this one is 4. We shall have our v is equals to 10 plus 2 times 4 gives us 8. So we shall have our v is equals to 18 meters per second. That means that at this point here, it is 18. Meaning that our body started accelerating at 10 meters per second, and then finally to 18 meters per second. So we are saying also that the final velocity here will be the initial velocity for the second stage. So let's first find the distance of this trapezium. So now we can find it because we know the value of b. We now know the value of a. We also have the height. So this time round we shall have it as our a is equals to a half ha plus b. So our a is equals to a half. The value of h is this time interval here. This is the height of the trapezium. So this one is 4. Then the short distance here, this hand here, is 10. Then we have plus b. The b is this long distance here, which is 18. So we shall have our area under the trapezium is equals to, this one will cancel with this 2. 2 will go here 2 times. So we shall have it as 2 into 10 plus 18, which will give us 28. So here we have 28. So now we have to multiply 28 times 2 to get the value of the area under that graph. So we shall have our 28 times 2. Our 2 times 8 gives us 16. We write 16, you carry 1. So you have your 2 times 2, which is 4, plus 1 is 5. That means 2 times 2 is times 28 is equals to 56. So the area under trapezium is equals to 56 meters. So what of the next stage? Let's look at stage B. Stage B. At stage B here, what is the shape we got here? Is a rectangle. So we are going to use the area of a rectangle to find the distance covered by the body when it was moving with a uniform velocity. So we shall have our area is equals to length times width. So what is the length? It is this short distance here. This is our width, and the length is the long distance, and this short distance is the time interval for it to move with uniform velocity. So you'll get 9 minus 4, which will give you 5. So here our width is 5, and then our length is from this point up to up, which is 18. So we shall have as 18 times 5. So what is our area here? Will be 18 times 5. What shall we have? We have 5 times 8. What will you have? You will get your 40, which is 0. Then you carry 4. Then 5 times this times 1 is 5, plus 4 is 9. So which is 90. So at this point here, that means that it is 90 meters. So the distance covered by the body when moving with a uniform velocity is 90. It is this timing here. It is this distance here. So now let us look at this. What of stage C? What happened at stage C? We have stage C. What shape do we have there? In stage C, we have a triangle. It is this stage here, when the body was coming back to rest. So this one here is at the height of our triangle, which gives us 18. And then we have the base of our triangle, which is 3. So we shall have our area is equals to a half base height. We say that our base is this one here, the time interval for it to come back to rest. For it to come back to rest, it took the car 3 seconds. So we shall have it here times 3, and the height, this one here, is the 18. The height there is the final velocity. To get our height here is the final velocity, actually the final velocity of the second stage. We are using the initial velocity at this point because our initial velocity of the the final velocity of the first stage becomes the initial velocity of the next stage, and it becomes the height of that shape. So we shall have it as which is 18. We have our A is equals to divide by 2 is 1, by 2 we shall have 9. So our 3 times 9, what is 3 times 9? We shall have it as 27 meters. So if we have all those, now what do we get as our total distance? Because they are not telling us to find only the distance at every stage, but they want us to find the total distance. So we are just finding it stage by stage, because if you know all the distance and at what stage, that means that you're in position to get the total distance by adding all the distances at each stage. So here, to get our total distance, if you're getting our total distance is equals to the distance of stage A, which was 56, plus the distance of the second stage, which is 90, and then plus the distance of the third stage C. So if we add all that, you will come up with the total distance covered by the body. So let's see. 56 plus 90, what will it give us? That will give us 146. Then we have plus 27. So if we have 146 and then add 27 in it, what shall we get? We shall have 173. So that means that we are going to be having a distance of 173 meters. So the 173 meters is actually the total distance covered by the car when it was traveling, from the point it started its motion up to the point it came to rest. So you see that this is all, it is the area under the whole graph. But there is something very different with stage A. If you don't want to use it, divide it as a trapezium. What happens? You see that a trapezium can have, it has 2 shapes inside it. What are those shapes? Let us look at this. If you have your trapezium here like this, we draw that. So we are having a trapezium here. We want to see, what if we don't want to use a trapezium direct like this? are the shapes that are inside a trapezium. It has got two. So you'll see that when you look at this, when you divide this from this corner straight like that, giving it a vertical line there, what happens is that this trapezium has been divided into a triangle and a rectangle. So instead, in case you don't want to, if maybe you've forgotten the formula of finding the area of a trapezium, you just divide this up to this point. You'll have a triangle, and then you have a rectangle. Since you know a triangle is formed from base times height, you can easily find that, and then you see that this one here, a rectangle, yeah, you will have it as length times width. So what will be here, if you divide it here, what will actually be the height this time? The height won't be 18 this time round, but then the height is from this point. If you divide it this way, this is now our height. So our height here is going to be 4. It's going to be the time for the body to move, to accelerate uniformly. So this is our time here, will be 4. And then the height, this is our height here, which is the time, which is 4 seconds. So what is the base? Because it is a half base height. So our base is here, this from this point up here. So you'll get from the initial velocity to the final velocity, you get the difference of the two. So if you get your 18 minus 10, you will see that you get the height of that triangle. So this is how we can find the distance and the velocity against time graph. So with this, we come to the end of our lesson. We shall meet again in the next lesson.